Yesterday, we went through a few definitions involving circles, as in the complete definition of circles. We talked about radius, we talked about diameter, then we calculated areas and circumferences. Today, I'm just going to lay out some of these notes in a little more detail to make sure when we're talking about circles that we are all on the same page as in terms of the definitions we're using. So let's go ahead and walk through these definitions here real quick. The set of all points on a plane. Oops, let's pick a color we can see here. I'm not a big fan of these fill-in ones because they just kind of leave out random words. This is a circle, so it's a set of all points about a given point in two-dimensional space. So this would be our center. And then we measure a distance, out. Let's say we want to measure 2 inches out. Then every single point that is 2 inches out, we mark. And when you mark all those points that are 2 inches away from that center, you end up with what we call a circle. And all those points, there's an infinite number of points. And so it does look like this smooth object that we know of as a circle. Blank, the blank that defines a circle, it is used to name the circle the center. So we name circles by their center, so it is the point. So here's our circle. There's the point that we're measuring from. And so this would be circle C. Blank, the blank whose endpoints are the center and any point on the circle. The segment. Segments have endpoints. So here's our circle. Let's give it a center C, and then endpoints are the center and a point on the circle, and that is what we call a radius. The blank, whose endpoints are both blank on a circle. So this is a segment because it's got endpoints. And in this case, are both blank on the circle. This is clearly a chord that they're trying to get. I'm trying to figure out what that word is right there because it's whose endpoints are both, I don't know, because this is what a chord is. Chord is, let's call this circle C again. Chord is any segment whose endpoints are both on the circle. So that's it. It could be any chord, okay, as long as the endpoints of that segment lie on the circle itself. There are special chords, okay? A special chord would be a chord whose endpoints are on the circle, like so, but it also goes through the center here, center C. And that is a diameter. So it's a special chord. So it's a chord that contains the center of the circle. So it's just a special chord. It is twice the radius. That is important. So diameter equals 2r, or radius equals diameter divided by 2. A secant is a line, that's going to be important, that intersects a circle at 2 points. So it has to intersect our circle. So there's our circle, and it just has to intersect it at 2 points. Okay? And it almost appears that any line that touches your circle would cross it in 2 points. So you would think that any line that intersects a circle is a secant. However, that's not true. We can draw a line that only intersects a circle at a single point. And if we draw a line that's just very carefully created, so it just touches the circle like that, it can strike a line or a circle in just a single point. And there's an infinite number of these. They just touch the circle at a single point. And that is called a tangent when it just hits it in a single point. So it is a line in a plane that intersects a circle in exactly one point. And then lastly, this point where it does touch it, that is called the point of, and then we get fancy here and we say tangency. I got that right. The point where a tangent line intersects a circle. So it's that single point of contact. Okay, and so today's stuff is just using these definitions and naming the parts of circles. So let's take a look here. Find the word that describes whatever they give you. So they've given us AB here. So let's highlight AB. Wow. And they didn't draw in AB. That's kind of interesting. So AB would go from here to here. It's kind of a strange thing. So this would be segment AB. And that's just a chord right there. Nothing special about it. Chords just have to have endpoints that lie on the circle. HB. Let's see if we can find HB. HB goes right there. That looks like a chord also. Remember, there is only one special chord. Let's see here. Line. Be careful. Note that little line notation. Line EG. Okay, here's line EG. Notice how line EG only hits it in that single point right there. So that is a tangent line. Let's see if we can find JK. JK right there, just another chord. Oops. Name the circle. We use a little symbol like that, circle C. Let's try another one. Maybe we get some radius, or radii, the plural for radius. Center of this circle is clearly C, right? It's just whatever's right in the center there. That means all these points are equal distances away. How far? Well, whatever the radius is. Radius. Oh, we have to name them now here. So here's a radius. We could go with CE. We could go with CD or DC. I'm going to go with segment CD. But there's lots of, at least 4 answers you could probably give for that. A diameter. Now, the diameter is a chord that goes all the way across it and passes through the center, so that's segment DE. A chord, let's get a generic chord here. AB would be a nice generic chord. A secant, remember, has to be a line that intersects it. So there we go. That's a line and it crosses it in 2 points. So that's line HJ. Note the notation here. We'll put the line symbol over it. Tangents. They want a tangent. That would be the tangent line. So right here, you can go with GF or KF or FG, FK. Just 2 points that are on the line. Remember, 2 points define a line. I'm going to take the outside ones, G and F, and put my line symbol over it. Point of tangency. We already found the tangent line, so the point of tangency is where it just touches it. And we'll just name that with a single letter. And the very last one here, let's find our center. There it is. It's G. Let's find a radius. So we go with or GF, or we could go with GH or HG and FG. So it doesn't matter. I'm going to go with FG here. A diameter. So now we need a chord that goes right through the center. There it is. FH or HF. Just a generic chord. I'm going to go with the KJ right here. And I'm going to make it a chord just by, when I write KJ, See, I put the segment over it, so we're talking about those endpoints that lie on the line. Now I can use it, though, as a secant as well. But if I use it as a secant, it's the line that intersects it in 2 points. Then my tangent here, we can see the tangents. Tangents are always relatively easy to find. It only hits it in 1 point. I'm going to call it AC, and it is the line, so we put the line symbol over it. And the point of tangency is where that tangent line just touches it. Okay. That's it for today. Your assignment is basically here's a diagram, and we ask you several questions, and you just have to answer, pick the one out of the lineup that is true. Is the center at K, at U, at segment KR, or